Yeah, man, it does come up one year.
Oh, okay.
So what I would do is, like I said, go to the library.
Yeah, he gave me the symbols. I'm not
Oh, that
copying
was
his work. I'm
nice.
just.
No, that's okay.
just-
You're allowed to copy down the problem so you can do your work and do it all in the course. You guys are quiet. Somebody died. Well, somebody dies every minute, but somebody you know died. I guess that was a dumb question. Just your soul for the next hour, I guess.
Thank you so much.
One question. You said that when there are three variables. So what you do is 2 to the power n minus 1, that will be the number of truth, right?
In the first column.
First one.
In the second column, it will be 2 to the n minus 2.
So it is 4.
Correct. So it'll be 4 in the first column, and then 2 in the second, and then 1 in the third.
Third, okay.
It just goes by descending powers of 2.
Got
It's
it.
probably the easiest way to remember it.
Got it. Now, is this because, say, for example, is this because of a binary thing? Because it's like, for example, if you had 1, 0, and half. So in that way, would the base be 3?
Right, that would be tertiary.
Tertiary. So in that
Yeah.
case, the base will be 3?
Generally, that's 0, 1, 2, if
Oh,
you were
0, 1, 2.
tertiary. Correct.
Tertiary.
Yeah, and that does exist. They used to actually utilize that. They didn't employ it much, but it did exist. So, I generated, when I was in grad school, I generated a mathematical program that would generate fractals based on a tertiary system. So it was actually pretty neat. So I don't know what happened to it. I lost it, and I probably couldn't do it now. Okay, so what I want to do today is I want to finish up our logical forms. I think the only stuff that we have left to do with logical forms is go through the statement forms with the truth table and then do the Boolean algebra stuff. And then I wanted to focus mostly today on argument forms, which are a little bit different than our statement forms. And then that should be everything that's on the first assignment. So our first assignment is going to be due at the beginning of class on September 7th. Okay, so over the weekend, as you guys are working on problems, if you encounter a difficulty, email me so I can try to help you guys out. Check back on the announcements. If there's a tough problem that I keep getting emails about, I might just post like a little part of the solution to it that where everybody gets stuck. Okay. So questions before we get started, guys? Okay. So correct me if I'm wrong, but I believe last time we ended up where we proved one of the statements to be true or a Boolean equivalency. And I think we just left off with the second one, so I said we'll finish up that one this time. Okay. So somebody remind me, because I forget things and it's been 2 days. What do I have to do to verify that these two statement forms are indeed logically equivalent if we use a truth table?
Left-hand side equals right-hand side.
Correct. We're going to make a truth table for both of the sides, and then we're just going to determine whether or not the two sides are going to be equivalent. Okay, so let's go ahead and work that through. If I focus on the right-hand side, I think what I might want to do is work inside the parentheses first. Okay, so I think the first column I might make after I set up the table is I might start with P and Q. Okay, and you guys remember from last time that for a conjunction to be true, both of the statements must be true. Okay, so true and true leads to true. True and true leads to true. And then I believe the rest of these are going to be false because each of the remaining 6 columns or rows contains at least one false for P and Q. The next thing that I'm going to do is I'm going to go ahead and say P and Q or R. Okay, so now I've done what's in the parentheses. Now I have P and Q quantity or R. Okay, so now we have a disjunction. And correct me if I'm wrong, guys, but for a disjunction to be valid, only one of the two statements must be valid. So if I look at the first row, okay, I'm just looking at these last 2 columns, and as soon as I see a true, I'm going to stick a true as the output for this. Okay, so true here. I see a true in the second column, true in the first column, nothing's true, true, false, true, just like we did last time, all we're doing is we're just kind of building out the statement, okay? So let me give you guys a moment to make sure that's okay, but are there any questions I can answer about how I designed either of those two rows? And it might have been a couple days since you guys have looked at this, so remember, conjunction, both must be true. Disjunction, only one of the two, or both could be true, okay? So what we have now is we have our right-hand side, or actually our left-hand side. Now what I have to do is I have to build the right-hand side. To build the right-hand side, we have our two parentheses. So what I'm going to do once again is I'm going to work inside parentheses. So we have P or R. Then we also have Q or R. And eventually what we want to get to is we want to get to P or R and Q or R. Okay? And that's going to eventually be our right-hand side. Okay. So, sir, please.
On my paper, A and B are the same question.
Are they the same question? Well, that's not good, because now I just wasted 5 minutes doing this. So, I apologize, guys. So I guess, and that's everybody else as well, I'm assuming, unless you just got a special paper, which I doubt it, so. I'm sorry about that, guys. What I'll do is I'll make up a new problem, and I'll post it on Blackboard for you guys, okay? So that way, at least you guys have 2 examples of this, so. My fault, guys, I apologize, not trying to waste your time. Okay, so we already know that this works, okay? What I did was I cut and paste the object, and I just forgot to change it, so. Okay, so we already know it works, so sorry to waste your time. Okay, so, more of a waste of time. The next method to be able to verify that Boolean statements are true, or these sorts of argument forms are true, is we can use something called Boolean algebra. Okay? So what I want you guys to do is the other sheet of paper that I gave you guys with the basic logical equivalencies. Okay? Pull that out, because these are going to be the rules that we need to be able to utilize to verify this by Boolean algebra. Okay? So, for right now, don't worry about the rules of inference. Okay? We're going to use those at the end of today. Okay? But for right now, we're just worried about these basic logical equivalencies. Okay? The way to think about these problems is you find the rule that matches and you just execute the rule, okay? And also, I want you guys to think of P, Q, and R. Don't think of them always as being P, Q, and R. Just think of them as like placeholders. So P is a variable, Q is a variable, R is a variable. That means there are 3 distinct arguments right there. Okay, so that's all those are. They're just 3 distinct statements for us to look at, okay? So, let's take a look at this first animal right here. Okay, so we have P or bracket, and I'm going to have to write this up, I apologize, not quantity P and not Q. And we're claiming that that equals Q. Okay, hopefully. Now, we could use a truth table to be able to do this if we wanted to. Okay, but let's see if we can use the Boolean algebra. You guys know that with regular old algebra, you work inside parentheses. Okay? So, if I was to ask you guys to use one of the rules that's on this sheet at this point, okay, and we're working inside the parentheses, okay, does anybody think they might know one of the laws that's on here that we could utilize to maybe simplify what's in the parentheses?
Distributive?
Not the distributive law, unfortunately. Good try. You're on the right track, but it's not distributive. De Morgan's law, okay? Guys, take a look at De Morgan's law, which is the third from last one. Okay, it's almost like a distributive property, which is why you may have confused it, sir. But that's okay. De Morgan's law says that if you have a negation on the outside, you can take it and almost distribute it, okay? So this is going to turn into, by De Morgan's law, P or bracket, this hops over, so not P. The and flips to an or, and then we have not Q. And that's supposed to be equal to Q. And each time you guys perform an operation, make sure you write what step you utilize to get to that point, okay? So again, all you guys have to do is just figure out which of those you're using, and then just write the step. Okay, so does that make sense, guys? That's easy, okay? I think the next step is almost like I'm going to beat you upside the head step, okay? So not that I'm going to beat anybody upside the head, so, sir?
So not Q, that becomes Q, right?
That's exactly right. Not Q becomes Q. Now we need a justification for that. So what rule is that, guys, on the sheet? double negative law, right? Okay, as soon as you guys see a double negative, you guys have been programmed since you're like 5 years old to see two minuses in front of itself. So we have P or, not P or Q. And that's supposed to be equal to Q. Good. And that's our double negative. Anytime in this class, if you guys see a double negative, you don't actually have to show that step if you just want to skip it, okay? Because I get it's a double negative, almost everyone on earth gets a double negative that sees this. Okay. At this point, guys, there's only one rule that we could possibly use to get to our answer. Okay? So,
Distributive.
not distributive,
No, not
okay? And you're
distributive.
close. But notice that the two logical connectors are the same. In the distributive property, one's an OR and one's an AND. So
Indeed.
basically, you need three statements joined by the same logical connector.
Absorption.
Not absorption, because again, I think this one would have to be an AND for it to be. That's okay. See if you guys can find a law where you have two of the same.
Why does the symbol change from an and to an or?
Oh, because when you use De Morgan's law, De
Oh,
Morgan's
Morgan's
law
law,
says
I
that
see
it
that.
does flip over.
Oh.
Okay? Do you see
Associative.
that, sir?
Yeah.
Okay,
I
cool.
see it.
Sir,
Associative?
the associative law, right? The associative law is the only one where you have the same logical connectors. So let's just move those brackets over. So this becomes bracket P or not P or Q is equal to Q. So this is our associative. Nice. Good job, guys. And then I believe that there's something right on the worksheet that says P or not P. Okay, so what happens when you guys see P or not P? What law does that fall under on the worksheet here? Negation law. Okay, so negation law, take a look at that one. Okay, that's like the fifth one down or sixth one down in the middle. If you have P or not P, that's equal to T. And guys, what does T mean in our class?
Truth.
Tautology, right? A truth, okay? So whenever you guys see like a T, that just means it's a tautology. Okay? So we're going to have, this is T or Q is equal to Q. Okay, so that's our, we said negation. And then there might be a law that has T or P or T or Q in there. It probably has T or P in there, okay? Remember, P is just a placeholder. It can be whatever variable we want, okay? So what law do we have there, guys, that
Identity.
says identity law? Okay. Take a look at the identity law, guys. It says that if you have P and T,
Yeah, the T or.
so unfortunately it's not the identity. You're close.
No, but it's a P or C.
Right, but we don't have a C, we have a T.
Okay.
Keep going down, you're really close. It's going to be the universal bounds law,
Universal.
okay? You're on the right track, just make sure the connector's on the right
What
side.
is C then?
C is contradiction.
Oh, contradiction.
Okay? So remember guys, whenever you see T, it's tautology, C is contradiction. Okay? That's a good question, okay? Because we didn't define those, I don't think. But you're absolutely right, guys. By universal bounds, Q is equal to Q. Okay. So this is valid. All right.
Do you have to memorize this or are you going to give it
No,
like
sir,
that?
okay? If you want to memorize it, you're welcome to, okay? I'm not going to stop anybody, but as long as you guys don't write anything on this, either front or back, okay, other than maybe I hate Chris Jones's face, that's fine, I don't care about that. But anything of use, okay, don't write it on there. You're certainly welcome to use this for an examination, okay? All right. Guys, this is a fairly difficult thing to do, by the way, okay? So a lot of students have a lot of trouble with this. The only way to get good at it is just keep reviewing it and practicing it. Okay, so we're going to look at a couple more of these. So if you didn't get it the first time, we'll look at a few more. But my suggestion, guys, is to make sure you have the logical connectors, make sure it matches up almost exactly. Okay. All right, our second example. Okay, a little bit uglier. So not quantity, P or not Q. And then we have an or, not P or Q, and Q. And that's supposed to be equal to not P. Okay. So, again, I'm hoping the first couple steps might be fairly obvious, and then it might get a little bit tougher from there, okay? So, does somebody think they might know what the first step is for this thing? Go ahead, sir. It's De Morgan's law again, okay? If you have a not on the outside of parentheses, kick it out with the De Morgan's law, no matter what, okay? It's the best thing you guys can do to start this, okay? So, by De Morgan's law, the not goes inside the parentheses, so it's not P. And remember, the or flips over and it becomes an and. I'm just going to write Q in there, even though it's technically not Q. All right, I just don't want to waste a whole step writing not Q in there. Okay, and you guys know it's a double negative. Okay, you guys know that all your life. Okay. The second set of parentheses remains exactly the same. So not P and not Q. And that's supposed to be equal to not P. Okay. So that's De Morgan and double negative. All right. Everybody in here can do that. I know you guys can do that. All right. The second step I think is very sneaky. Okay. The last problem we had, it was just like brute force. This one needs a little bit of finesse with it. Okay. Does anybody think they might see a rule that follows the pattern to where we have an and in parentheses, and in parentheses, and then an or on the outside of those two parentheses? And if so, what law is that?
Distributive?
It is the distributive law. Very nice, gentlemen. Okay? Take a look at your distributive law, guys. Okay? It's third one down. And we're actually looking at the first of the two distributive laws. It has P and Q or P and R. Guys, what we're going to do is we're not going to distribute, we're actually going to go backwards, and we're going to actually factor out the common term. Okay, so it's actually logical factoring, if you would. So if you guys were to go backwards from the distributive law, okay, so let's just go ahead and write that up, that this is going to be equal to not P, and this is our distributive law. Does somebody think they might know what the, and I'm going to say this in quotation marks, the factored form of this might look like? In other words, going backwards. So we're looking at the right-hand side, and we're trying to make it look like the left-hand side. Anybody think they might know that?
Not P times not P becomes P, right?
So, well, it's still going to be not